1.2. 1.2.
Write it all out.
You can summarize it. For instance, number 77, the question is written in words, but can you write it in notation? What would it look like? I'll model
The
one.
limit of s goes to pi
Of?
h of x.
So x.
X.
Ta-da, see? That's number 77. Does that make sense? 77, 78, you need to kind of draw the picture. But 79 is another one where you can just kind of write the problem to, and then number 80 is a piecewise. I'm going to turn off the front light, my projector, Mrs. Christensen got me a new computer, which is really cool. Hopefully it won't die, like the other one was dying. But the wording's kind of hard to read when the light's on. So you're labeling it. Sorry, section 1.2, NC practice, multiple choice practice. These are not exact AP questions, but to be honest, we're not quite ready for exact AP questions. You'll see some soon. But these are very similar, similarly patterned. AP Calc, there's only an A, B, C, D option. No E. Very good. Except that that's the one they took out was one of the easy ones that you could have eliminated it. That's okay. Still a 25% chance, right? All right, do the best you can. Remember, you're in the back of your spirals. Section 1.2, multiple choice practice, MC practice. Let's see how you can do on the 4 that are up there. P.S. You probably don't want to take more than a minute on each, and hopefully it's less than that on most. Are they still writing questions? Can you still see? Okay. I'm recording your guys' lecture because I was a few minutes late to class, and then Mrs. Christensen thought I'd be a lot late to class, so then she was setting up the new computer, so anyway. Period 1 was interesting today. They're watching the end of your class to try to get the rest of the examples. They theoretically started their homework, but not really. So it's up to us. As you guys finish, I don't know how I forgot this day after day after day after day, but you guys never got your calculus letters from last year. I was so sad. I don't know how that happened. Last year's AP Cal kids wrote letters. I actually have in your shared folder, there's a letters of advice, and it shows scanned copies of all the letters from 2 years ago class and last year's classes, CalcAB and BC, just if you want to see any other people's. Some of them are very detailed and long, some of them are a little bit shorter, and there's fewer students than last year, so I may very possibly have some left over, some of you can get 2 letters, but I do write you ones of advice. Here is the prompt. In the space below, please write a letter to next year's calculus kids, sharing your helpful advice to those who are just starting this journey. What worked well for you? Is there anything you wish you had done differently? There's quite a few of those. What carried you through the more difficult sections? Be as specific as you like, and keep in mind that next year's students will be reading your advice. Technically, it says in August, so I had to get it to you before August. Somehow I gave period 1, but not your guys's. I'm just going to go ahead and. Do I have them in any order? Not really. I have them in no particular order. So, some of them are actually, there were quite a few juniors. Sorry, I'm just going to some of your videos kind of funny, but you got that one. So some of them are still here on campus. Those ones.
P.S. Don't do drugs.
Alright.
Do you all get that? You don't know George Floyd?
No, it's not your brother.
It was about your brother, though. Bridget and George, that was their joke.
You think I'm gonna get it, Jonathan?
And most importantly, don't.
No way.
I think I have enough you guys to get to.
Joshua wanted mine is very small. Bro, you're not giving John.
Signatures.
You know, I said I'm gonna get John. Better up.
I think we have enough for everyone to get to. We'll see. Oh, this one gave a number for you guys to call or text with questions.
That's cool. I would not do that.
We'll see how long this double thing works. Here is Zipperman.
I know.
Brianna Carson.
Make sure you memorize the serious. Come on.
Oh, I'm not sure if I can get all the way around, but I'm trying.
I don't know who this is.
Oh, she did great last year.
Really? Oh,
She had an orchestra. Yeah, she looks. She was super sweet kid. She loves horses. And she left really. He was BC, but go look at the scan. He actually did a really good letter. I was very proud of him. Aaron called her on that.
Even younger.
Yeah, Aaron, can I read Aaron's?
I have Chris or I have Sam. I have 2 boys. There you go. They're both boys. You get one? First, you guys, you can switch around to read someone else's if you want. But they're all scanned and they're all online. If there's someone that you want to particularly seek out their advice. Huh?
Yeah, Brendan Republic, yeah.
Brendan!
Yeah, I wonder what this version to 0.
They actually tried.
Oh, yes.
You guys can switch around if you want some other
Yeah,
stuff.
look out the verse.
Yeah, you can look at it.
I mean, like, look at it, but also.
Yeah, you can look at it.
So sorry.
I don't know a word, but yeah. A word who wrote.
Let's see.
Charlie's writing is very artistic.
It's not one word.
This one?
My only hope. Oh, I like that. Who wrote that?
This one? Charlie.
I don't think I wrote it.
Oh, I don't know, someone who was in here yesterday. Anybody know who it was? It was cross country.
That was really.
Invest.
I'm
Invest in your
so
friends'
much.
lives. That's actually really good.
Yeah.
I forgot to give you like all senior advice.
Why are we running today?
Okay, we're only doing music and
There's
music.
someone across country in there. I just want my best. Yeah.
You have three? I have three letters. Because you took Aaron.
Yeah, I never
I'm
had it.
actually not supposed to get them back. You're supposed to keep them. I mean,
Oh, can you keep Aaron's?
Yeah.
you want to keep Aaron?
Didn't get to episode.
Alright, long story short, did they have some things that worked for them? Do they have some advice of what might they wish they had done better?
Not really.
Almost all of them have something to do with CalcAB and homework and studying. Forever cards are usually in there, sometimes zero period copying are in there, sometimes I'm in there for some reason.
I don't know how that pertains to.
We might just stop.
It's like we have to wait for our tape. I think go deep.
Motion is first semester. It's in, we actually start it like next chapter, but we kind of continue it for the rest of the year in bits and pieces. Alright, cool kids, let's go ahead and see how the multiple choice went. Those letters are yours to keep, and if you want to go online and see more, you may. As you guys tackled, let's go ahead and focus on it in your workspace. Thank you for letting me do that. I apologize, I didn't do it. For 77, 78, 80, no, 79, 80. What's the very first thing you should have tried, especially on 77, 79, and 80? Plug it in. So, on number 77, the correct answer was? Okay, now we're going to start using sign language because you guys aren't actually participating. So, C, because you plug in pi and then you end up with? Done. Okay, number 78, do you guys know sign language for A, B, C, D? A is this one, B is this one, C is this one, D is this one. A, B, oh really? That's cool. Okay, ready? Give me what you think it is.
Oh,
For number 78.
I don't do D.
Yeah, D is the one that put the fingers in.
It's D and P like this.
I don't know what that is. You're drinking tea? Okay, hold on, let me see. Okay. So, correct answer is none of the above, because technically it should have been infinity. But you could say D. You could say D. D is the best answer of the four that are there. Sometimes you have to choose the best, even though it is not the actual one. The better of that. You said best. The best of the four. Does not exist because as you come in, it is a vertical asymptote. But what should we express the answer as? Infinity. This is according to what the book has taught you thus far. This is according to the broader context of we can still give an answer. Yes, you got it. Number 79, let me see. Good guess though. If you were on the test, you would take a guess. So what would your guess be?
Say.
Yeah. I see A's, I see D's, I see more D's, I see, okay, just pick one. What do you think? Pick one. More A's?
I thought
Cameron,
it
pick
was
one.
a question, so it would be.
I'll do A because my name's.
Okay, picking D, more picking A's. Okay, the final answer is, I'm not gonna tell you yet. How should you have solved it?
Plug it in.
Okay, but what happens when you plug it in?
Zero gets zero.
Oh no! 0 over 0, keep going, but how?
Take out.
This entire section was about looking at and dealing with limits graphically and numerically. So what could you have tried to do to figure out what the actual answer should have been on 79? Pause. If you did not yet, go to your calculator. Let's see now, and you guys confirm whether you were right or wrong. You can use the graph or a table.
Oh, let's see. So, we don't actually have to like hand graph it. We can just use a calculator.
On number 79, yeah, because I'm going to tell you in just a second about how the actual way to solve it requires you to know a semester of calculus. Not a semester, maybe just like 3 months, but still. So as you guys are doing that, I am doing the other way, which isn't a bad way. Oh, yep, I know the answer. Okay, you guys got it? Use the graph or use the table. Where's the little zero is undefined? So f of 0 is undefined, but the limit, remember, I can have a whole one and still have a limit.
I grabbed it, I shot it.
Well, that's actually enough.
As it's approaching.
Yep, as x approaches 0. Yeah.
Is there gonna be no calculator section with that?
Wait, what?
AKA, if I want you to do a table, it better be something easier on the calculator portion. And if I want you to do the graph, either it has to be on the calculator portion or I give you the graph.
I know that C is the opposite.
Do you?
Yeah.
Me too. The answer is, where it's almost no one's guessing.
Wait, what? I just put a.
B. What?
Because you plug
What'd you do in
it
your calculator?
2.
Okay, you didn't put 2 in your calculator.
Oh, I put in the equation, but I got
No,
it.
that's in the
Back in grade school. Do you have something like that?
Wait.
Yeah. I feel like
As x approaches.
I'm totally, I feel like I laughed at it. Have I laughed at it? Kennedy.
What was it called again?
How is it?
And then the other way with -3.1 negative.
I can have it.
How do you guys approach your table? Help me out. How do you approach 0?
You just put in.
Negative 0.00001, right? 0.00001. Do some scientific notation in there. With the e. Okay, but yes, the function is approaching 2. My way, you'll have to wait to learn. Number 80. Okay, let's start with number 1. Number 1's not too bad, right? Roman numeral I.
Yeah.
Looking at that, we're either going to say yes, check, it's true, or x, it's wrong. Does the limit as x approaches 3 of the square root of 3x minus 2, does it equal 1?
Yes.
Yes.
How do you know? Plug it in, and 3 minus 2 is 1, and the square root of 1 is 1. Is that true?
Yes.
Yes, I should say check marks are good. Some people say check marks are bad, like marking it wrong, but that's not me. Number 2, does the limit as x approaches 3 of 6 minus 2x equals 0?
Yes.
Yes, because you plug it in, right? 6 minus 6 is 0. Number 3, does the limit not exist?
Yes.
No, because those worked. Pause, you're wrong. Question. What kind of function are we looking at in number 80? Piecewise. So if we're trying to find the limit as x approaches 3, I need you to pause wherever you are, whatever you're thinking. Some of you can be here, but not here. Happens all the time. I need you to focus and be here and paying attention. If I need to find the limit as x approaches 3, don't I have to check both sides? Below and above? Someone tell me, if you were in your table trying to check below, what's something you would plug into your table? 2.9. Or 2.99, 2.99. Okay, 2.9. What piece does 2.9 go with? Top piece or bottom piece of my piece one?
Bottom.
Yeah, less than 3. 2.9 is less than 3. So if I'm trying to find this one, where would I plug that 3 into? The bottom piece. 2.9, 2.99, 2.99. Below 3, plug it in. So what did we just say this limit was?
0. There's going to be 0.9.
So as we plug in 3 above, give me a number that you would put in your table.
3.1.
What piece? Top piece. So I would plug in the limit as x approaches 3 of square root of x minus 2. We just said that equals 1. Why does this prove that number 3 is true?
Because it's satisfied.
If the one-sided limits do not agree, the limit does not.
Exactly.
So therefore, that is also true. Dun, 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 50. Okay. It's D. All 3. The first 2 prove the last one, but do you see how piecewise ones are a little complicated? Could you have gotten this in your calculator using pre-cal graphing calculator handbook stuff from last year?
Yeah.
Yeah, and then what would you have seen at 3? A break. This one coming towards 0, this one coming towards 1. You would see a break. Okay? All right, let's move on. P.S. Were you guys grading yours? Good. Abby got it. Colored pen. For word to the wise in the future, it might be helpful to grade like you do homework, treating these like little pop quizzes and being like, pause, get out a colored pen, mark any of the ones you got wrong just so you know I better study this one. Does that make sense? We don't want to waste all of our practice. We don't want to say this is for nothing. This is for something. And not just in the moment, but also for the future, learning from our mistakes and our weaknesses. And we've only gotten through what, like 2 sections? So we're gonna do more work with limits. And a lot of these things we're gonna review. And notes for section 1.3, which maybe we'll finish because we actually have our whole class grade, unlike grade 1. We are gonna actually take a page of notes on number 80. So we'll talk about piecewise function. That was not the end of piecewise function and limits. Functions and limits. But just make a quick little star, a quick little note, and once you guys have shown which ones you better look at again as you're studying for the limit test, etc., go ahead and put that spiral away, get out your composition books, let's go. Yesterday we got some tedious stuff done. It's important. It's important, but a little tedious. Uh-oh.
Oh, what if we didn't finish?
Are you on this page?
Yeah.
Okay. I'll pause here for a second. We get to have some fun if we can just get past the tedious. Now, for some people, the deep theory is fun. It's just not so fun for me. It wasn't always my favorite. So when I say let's have some fun, we'll start doing some problems, basically. But as you guys do, don't ignore Psalm 39:7 is great, but look to the red writing on the board once you finish writing down the well-behaved functions. The times where direct substitution is great, is perfect, is enough. What you don't see are piecewise functions. Direct substitution is part of it with piecewise, but not all of it. So we'll talk about piecewise a little bit later on today. But in context of what we were doing yesterday, we built up to the point where we're like, sweet, plug it in. If it works, awesome. As long as it's not a piecewise. But the question we're trying to answer today is, starting with rational, but expanding to more, what if it doesn't work? I'll give you a couple more moments with the what if it works.
Are we getting our summer packet?
I was going to, you didn't hear the beginning. I was way late today because of a very bad accident. So, since I was late in period 1, I kind of just left the whole passing back thing until tomorrow. If you want it, you can come by after school and grab it. Your pile is the 3rd one in the summer packets, and then your quiz is the one, I'll get your quiz, just let me know. But I'll go ahead and just update. I was going to update Runweb today anyway. Usually I try to do it after I pass back things, just because, I don't know. I don't think it's bad to put in grades before you see them, but if you get a good grade, you're kind of like, oh, sweet, whatever. If you get a bad grade, you're like, oh, I failed. I'm done, right? I don't really want you to feel either of those. I want you to be humble and not think you have it all, because you probably made mistakes. And I don't want you to think that you failed and you're dumb and you're done, because we can still learn from mistakes even after a test. But I'll probably still update Runweb anyway, just because stuff got delayed, so. Anybody else get stuck in traffic today? Yeah, Mrs. Leon, well, I was able to be on the 14 on Newhall Avenue,
Okay, what was it?
but it took me a long time to get across town, so I usually go on the 5. I looked at Waze and it was like 1 hour and 6 one way and it ended up being 1.5 hours. And then on the other way, going the 5, it was like 1 hour and 52 minutes. I was like, no, go this way.
Wait, what is it? I mean, like, where was that?
San Frida, the accident was, you know how the 5 and the 14, if you know the map at all, they come down and join and then go down towards LA?
Yes.
It happened right before the 405. Roxford, that's right before the 405. And so I live, this is Santa Cruz, I live like, not Castaic, but a little bit.
The old road,
Oh, yeah. The old room's awful. Madame, there's a group chat of Madame, Mr. Horn, and me, and Madame, Mrs. Christensen heard on the news, texted Madame. Madame was like, there's an accident. We're all like, run to the cars! And we all went. Madame took the 5. She didn't figure it out until it was too late. And she tried the old road and she got back on the road.
That's what I did.
And she got here after me and she left at least 15 minutes before me.
I left at 6:50 and I couldn't see.
I left at 6:35 and I was here at 7:58. Anyway, here we go. those of you that didn't care, sorry, a bit about our lives. Okay, anyway, at least it wasn't a car accident. Physics. Anyway, so, let's keep going. This is plug it in, simplify, you're good. Examples, guys, you don't need a lot of these. We did some in multiple choice, so I'm going to actually skip this page, but I'll do one. What if I was to do something like the limit as x approaches e of e to the x minus 2 all over 3? There you go. What would you do? I like it, say it loudly. What would you do? Yeah. Doesn't make it over 0, doesn't make an imaginary number, doesn't make anything bad. It's not a piecewise function. Plug it in and say, I have no clue what's going on here, but sure, it sounds good, and it is. It's perfect. So plug it in, plug it in. No matter how messy it is, as long as it works and it's not a piecewise, you're okay. But that begs the question, sorry, questions on the example, going once, twice? Yeah,
What actually happens when you raise e to the e?
means e to the e. You have 2 point something raised to the 2 point something, so it's something bigger than 4, but probably less than 9. 15? Oh, because it's 2 point, yeah, that's right, e is bigger. So I should have thought of 3 to the 3 and then gone a little bit less. So something less than 27 and bigger than 4. Well, that's a wide range. Anyway, you get that. Go team. Okay. But, what if it doesn't work? If you have a rational function, nice thing is still summer review, but I need to write a few things down and have you guys, well, writing things properly as well. This summer you might have formed some bad habits, and last year you might have formed some bad habits if you did not do things the way I asked. Not to say it's impossible to change it, but 0 over 0. Either you've heard it from me this year or you remember from last year. What are we supposed to do? KG, keep going. Why? If you plug in a limit problem, you get 0 over 0. My question to you is, does the function value exist? Nod ahead, yes or no, my quiet ones. Everyone, nod ahead, yes or no. If I plug in, you get 0 over 0. Does the function exist?
Yeah.
Sometimes.
No. No.
Yes.
No?
Sometimes.
Just tell us.
Now I have this going on. Okay. Does the function exist if I get 0 over 0? No. Okay, pourquoi? This is undefined. 0 over 0 is undefined when you plug in, but what are we solving for?
The limit.
The function value does not exist, but is a whole enough to say that a limit doesn't exist?
No.
So the function value does not exist, but we have to keep going for the limit. The function value does not exist. You're dividing by 0. Yeah, you're right. It doesn't exist. But what kind of discontinuity is a whole? Removable. So we're going to remove it. Keep going to remove the whole. If it's just a whole, we've talked about how, as long as the two guys are approaching, I apologize, as long as the two guys are approaching the same intended destination, the limit exists. The diner might not be there, it might be burned down, it might be closed, but they're meeting, for all intents and purposes, they're approaching the same intended destination. Yes, the limit exists. But how do we do this algebraically if we try to plug in and it doesn't work? We say, hey, that's called indeterminate, which means we can't just say DNE. That does not determine the answer for us. We need to go ahead and try to remove the whole that is present or seems to be present by 0 over 0. And how do we do that? Well, there's basically 3 different things.
Okay.
Last year we had, I had multiple slides on each probably. This year, well, 1, 2, and 3. Try to divide. How? I don't know, factoring and canceling if possible. Synthetic division and long division if you have, or long division, if you have something nasty like a cubic or a quartic and you don't really want to try to factor that. Try dividing. If dividing doesn't work, or if factoring is not really an option, because you have things like, anybody remember when rationalizing is useful? What's present in that function where you're like, ooh, I think I better rationalize? Square root. There's a square root. Most of you are like, yeah, let's not factor. If you have the square root of x, most of you are like, let's not factor. And do you remember how I fill in the blank? Multiply by the
Conjugate.
conjugate. Nicely done. And not just any conjugate, but the conjugate of the expression with the square root. We need to get that square root out of there. Unless you don't mind factoring with square roots, in which case it might not be a problem. And last but not least, I was not just being facetious, I was being literal with that. Sometimes you can factor with square roots. Last but not least, simplify complex fractions, and all of you should be like, summer packet, we did that. But that's not the only type of simplifying I'm talking about. Why am I saying simplify truth? You do have identities. Trevor Carden for one, in fact. Every now and then they might come in handy. There's one more case. This one is, what if you get 0 over 0? There's a hole. Try to remove it. If I can remove the hole, I can see where the function was intending to go. If I can remove the hole, I can then plug in after it's gone and say, well, where were you meant to be, but you couldn't be because of that denominator. Ultimately, kind of what's going on. So you could get 0 over 0, but question, what's another way of getting 0 in the denominator but not having a 0 up top? What's something else that could be up top? That was too hard of a question, wasn't it? If 0's not up top, but something is, tell me a number that could be up there. 2, sure, what else?
12.
12, what else?
Pi.
Pi, what else? 4, what else?
6.
How about a negative number, like negative 123, just to be exciting? Any number over 0, what do? You still have an over 0. It still does not exist. It meaning the function. The function still does not exist. There is a discontinuity at whatever it is that you're trying to approach. F of x does not exist. But, what is there? Well, let's talk about this. The function does not exist if you get an over 0. If you get a number over 0, the function does not exist, but you do know there's a vertical asymptote there. This form is called infinite form. Vertical asymptotes are called what kinds of discontinuities? If holes are removable, vertical asymptotes are not removable, otherwise known as non-removable. Same idea, right? Which means, do we keep going to remove it?
No.
We'll get quite frustrated quite quickly. No. Not keep going to remove it. So what do we do? Ready? We write plus or minus infinity with a question mark. Why? As you're coming in towards a vertical asymptote, the function's going to have to, right? Do something. Yeah?
Yeah.
There's going to have to be some sort of infinite limit somewhere. Now, careful. In parentheses, I'm going to say check signs from both sides. And hopefully in just a second, you guys will be able to answer why I'm putting that. Let's put a parenthesis, and then it's always not as big as I want it to be, and I have to redo it. There we go.
Misty, why did you put the question mark here?
Hold on, pause. Let's see if you can answer that very thing in 1 second after I draw 3 little graphs. Ready? Limit as x approaches a of f of x. A vertical asymptote is there. Question, what could happen as I come in from both sides of a? Just what's something that could happen? They could both go to positive, I'm assuming, yeah? If they're both going to positive infinity, I would say the limit as x approaches a of f of x equals what? Positive infinity. What else could happen? They both go down. If they both go down, what would I put as my answer to the limit as x approaches a of f of x?
Negative.
But what else could happen? Whether it goes one way or the other. Start singing this song. The limit as x approaches a of f of x, if this is the case, what's going on? Dilemma, can I just say the answers are positive or negative infinity? No. So why do I have to check the signs from both sides? It's a possibility that they do not agree. So, let's pause and let's think. In preparation for the examples that we're going to go over in the next page, what is something, let's assume, example, let's assume A is 4. The vertical asymptote is at 4, which means I have some denominator x minus 4, or x squared minus 16, something like that. I have a vertical asymptote at 4. What is, think table, think calculator, what is a value you could think of plugging in to check where it might be going from below? Just think table, below, what's something you can plug in, below 4? Nope, below 4, real close, let's not go crazy out. 3.9. Now, why am I not saying, sure, let's go down to -5? What if -5 is a negative number? But where is it going as I get in, zoom really close in towards A? It's going up. If I can plug in 3.9, 3.99, 3.9999999, and it's a positive number, it's going up. I promise. If I plug in -5 and it's negative, I have no clue what it's doing it for. Okay? Now, what if I plug in 4.00001 and it's a positive? What can I assume? It's going up. 4.1, 4.01, 4.001. All we care about is the sign. Is it above and keep going? Is it above and staying above, or is it below and going below? So if I plug in 3.9 and it's a negative, 3.99 it's a negative, 3.99 it's a negative, I bet it's going down. If I plug in 4.1, 4.01, 4.001, it's a negative going down. But what happens when I plug in 3.99999 is a negative and 4.0001 is a positive? DNA. So, you guys ready? Let's have some fun. lots of examples. Let's make them all. For sake of time, we're going to do them together. Your time for independent practice will be tonight and your homework. You ready? Number 1. Who has thought of something to start with? Pause. No. We should always start with doing what? Plugging in. And what do you get when you plug in? You already checked it? You're sure? Good. So, how do we keep going when there's a square root? Multiply by the conjugate. Of which piece? The bottom or the top? In this example. In this example, top, whatever piece has a square root. I need to get rid of that square root. It's messing me up. Why am I putting parentheses everywhere? What do I see kids do time and time and time and time and time again? Not distribute, not fill. So, we need to FOIL top and bottom. However, where's the Y's? I'm going to FOIL the top, but keep factor at the bottom. I promise, it's easier that way. When I FOIL the top, difference of squares. The first one squared just becomes a 3x. Think about it, it's true. Outer and inner cancels, 3 and 3 is 9, but with a minus sign. On the bottom, I get x minus 3, keep it factored. Radical 3x plus 3. Plug it in, still 0 over 0. What do I need to do? Factor the top, take out the common 3. If I take out the common 3, what is now matching with the bottom? What am I going to do with it? Remove the whole. After I remove the whole, what am I now trying to do? Plug it in, and I end up with 3 over radical 3 times 3 plus 3, which ends up being radical minus 3, 3 plus 3 is 6, 3 over 6 is 1. Double check the mental math. But I believe it is good. Now pause, something super important for kids that didn't have me last year. Where did the actual notation, the limit as x approaches 3, stop being written? What changed
When you
from
substitute.
all the rest when I substitute? If I'm substituting, the limit disappears. If I'm substituting, the limit disappears. But until I substitute, what cannot disappear? The limit. So look at your work. And right now, if you're one of those that you're like equals, and you're not rewriting limits, that is incorrect. I'm so sorry, but it's true. You have to keep writing limit. It's like you imagine, like you just are square root. Oh, someday I'm just going to forget the square root. That's awful, right? That's not math. Keep writing the limit. I'm sorry, it's true. I'll take off points if these don't follow the process of rewriting the limit until you plug it. Number 2. Plug it in, what do you get? 0 over 0, keep going. Ugh. How? Oh, how do you keep going on this one? But what's like the general process we're going to be doing? Simplifying the complex fraction. How do we do it in our summer packet? Multiply by the little baby denominators. And what are they? And? Don't forget them. Got to do both, top and bottom. Either that or get common denominators up top and make the bottom x over 1 and divide by multiplying by the reciprocal. If you want to, just don't be wrong. As this comes in, what cancels with the first one? As I distribute this whole shabam. The x plus 2's cancel, and what's remaining? The 2. What happens as I distribute to the next one? 2 cancels, what remains? Don't forget your parentheses, that negative needs to distribute. The x is still there, the 2 is there, and I still have the x plus 2. 0 over 0, keep going. But what do I need to do? Yeah. Can't the 2 and the minus 2 cancel out? So the 2 and the minus 2, the negative distributes. I have a negative x left over. Wait, what does he do with the bottom? He reduces. So what do I really have left? The limit is gone because I am plugging in negative 1 over 2 times 0 plus 2 ends up being negative 1, 4.
You kind of go back.
Yep.
to the-
I distributed my negative. The 2's cancel. There's an x and x up top. Canceling out the 2's, reducing the x's. Pause, I'll write it in my board because there's not a lot of space over there. I had 2 minus x plus 2 all over 2x times distribute the negative. What cancels? Then I have negative x all over 2x times x plus 2. What reduces? Got it. Now, I'm not writing the limit because I wasn't solving the limit. I was showing you the algebra, but now I'm writing the limit because you guys will get mad at me. Got it. Then plug in and get to where I got. Number 3. Plug in. What do you get? Oh. Really? It's like I was designing these or something. Design. We could go, no, pause. Go outside. Factor. Do you remember SOAP from Algebra 2? Pause, time out. Ironically, you got about the same place as period 1, but you got to see these two solved. They didn't get to see anything solved. We're going to continue in 1-3 tomorrow, a little bit more, but we're starting 1-4 the second half. Get as far as you can in homework, but pause. What would you do? I would do long division or synthetic division. The T goes into him. Over here, number over 0, which of the 3 cases? Same with him. I'll see you guys tomorrow. Get as much time as you can. We will finish up these notes later as well. And I see you guys both classes are about the same.
No, I'm always.
Why don't we just go Monday? So Monday's same opposite. Let me take together.